Hello students, this is Mr. Parseghian. Today we are going to discuss isotopes and average atomic mass. Here we see models for three different carbon nuclei. Take a moment and notice the similarities and differences between the three nuclei. Hopefully we notice that all three nuclei have 6 protons. The number of protons identifies the particular element. Any atom with 6 protons is carbon. Any more or less protons, and we have a different element. We also should have noticed that each nuclei has a different number of neutrons, 6, 7, and 8, and thus a different mass number, 12, 13, and 14. The varying number of neutrons gives us 3 different versions or isotopes of the element carbon. When we find carbon on the periodic table, we notice that, like most elements, the atomic mass is not a whole number. This is because the atomic mass displayed on the periodic table is a weighted average of all the isotopes of a particular element with consideration to each isotope's abundance in nature. Carbon-12 is by far the most abundant isotope of the element carbon, thus the weighted average is very near 12. We are going to learn how to calculate the average atomic mass for both real and hypothetical elements. If we could zoom in and see the individual particles that make up this sample of copper, we might see something like this. Pause the video and draw the individual particles, paying attention to how many of each size particle is present. As you can see, our sample contains 7 of the smaller copper atom and 3 of the larger copper atom. This is because copper has 2 prevalent isotopes, copper-63, which makes up approximately 70% of any sample of copper, and copper-65, which makes up approximately 30% of any sample of copper. We say that copper-63 is 69.17% abundant, and copper-65 is 30.83% abundant. You can see that the average atomic mass of copper is 63.55 atomic mass units, or AMU, which is closer to the more abundant isotope copper-63 as compared to the less abundant isotope copper-65. This table shows some common elements and their isotopes. Elements can have varying numbers of isotopes. Chlorine, copper, and silver have 2 common isotopes, while magnesium has 3. Notice how the percent abundance of the 2 isotopes of silver are nearly 50-50. Take a moment and locate the average atomic mass of silver on your periodic table. Because the 2 isotopes, 107 and 109, are nearly 50-50, the weighted average is nearly right in between the two at just under 108 AMU. The following equation can be used to calculate the weighted average or atomic mass of any real or hypothetical element when given the masses and percent abundances of each isotope of the element. Using the information in your note packet, let's work together to find the average atomic mass of copper. Here you can see that we've started with the equation for average atomic mass, and now we're going to substitute in the mass and percent abundance for the 2 isotopes of copper. Our first isotope, copper-63, has a mass of 62.929599 AMU, and the percent abundance is 69.17%. We would like to write that as a decimal, so 69.17 out of 100 is 0.6917. For the second isotope of copper, Copper 65, the atomic mass is 64.927792 AMU, and the percent abundance is 30.83%. Written as a decimal, that's 0.3083. At this time, take a moment and punch those numbers into your calculator, and let's see if we can come up with the average atomic mass. So hopefully, after having calculated and rounding to two significant figures, we come up with an average atomic mass of 63.55 atomic mass units, or AMU, which is consistent with the value for the atomic mass of copper on the periodic table. Now at this time, take a moment, pause the video, and find the average atomic mass of chlorine on your own. Here you can see for chlorine, we have substituted the atomic mass and percent abundance for each of the two isotopes. Chlorine 35 has an atomic mass of 34.968853 AMU, and at 75.77% abundance, we substitute in 0.7577 as the decimal form. Chlorine 37 has an atomic mass, or a mass number, of 36.965903 atomic mass units, and at 24.23% abundance, that's 0.2423 written as a decimal. If we calculate that, we should come up with a weighted average of 35.45 AMU, which is consistent with the atomic mass of chlorine on the periodic table. That concludes our lesson on isotopes and average atomic mass. We'll see you next time.